Welcome back, everybody. It's Mr. Conaway again. Today, I'm going to show you some of the really exciting stuff that the Arduino can do. We're going to start getting the Arduino to record sensors and send those recordings back to the computer using the serial monitor. So by the end of today's video, you should be pretty comfortable creating a circuit using sensors. And I'll show you a neat thing in the circuit called a pull-down resistor in a little bit here. You should also be very comfortable in the program or in the sketch using variables to remember measurements. Just like we did with robots, we're going to have to measure things and record those measurements into variables. We'll see how all that works. I'm just giving you a heads up of what you should be pretty comfortable doing by the end of the video here. All right, let's go ahead and create a new circuit. There's a lot to cover here. And the very first thing I'm going to do is rename this into assignment number 11. Now, I'll probably be using these videos sometime in the future, and the assignment numbers might be slightly different at that time, so just understand that in fall of 2020, it's assignment 11. I am going to start out with a few things here. I'm going to start with a breadboard and bring that in. You'll want to do the same. Please make sure that you are copying along with me. I'll bring in an Arduino. And remember, the goal of this assignment is just to get sensor data to go back to the computer, so we're not going to turn on any lights or anything like that. We are going to use some sensors, and it's sensors that we have already used before. So some stuff we're pretty familiar with, or should be. We're going to bring in a push button. Span that guy right across the middle. We are going to bring in a potentiometer, and I'll just get him as close to the middle as I can there. And last, we're going to bring in a photoresistor. So these are the three sensors that we'll be using. So before I go any further, let me explain the basic idea of what's going to happen here. We're going to give each one of these three things, the button, the potentiometer, and the photoresistor, 5 volts of current. We are going to send that current back to the Arduino so the Arduino can measure how much of that current is coming back, right? And we're going to send that measurement to the computer. So let's go ahead and get a couple of basic things set up here. So number one, I always like to make sure that I'm bridging positive to positive here. And I also like to make sure that I'm bridging negative to negative. So I've got that going on. Also, I need to give the breadboard its source of voltage here. So connect it to the 5 volt and also connect it to the ground. All right. Well, if this was Bob Ross, he'd say, well, isn't that a happy little circuit? And I think it is. All right, let's get into the brass tacks of things, though. We want to give current to each one of these three things and then measure how much of that current comes back. Let's start with the button here, all right? I'm going to give current to the right side of the button, so I'll start where current always starts in the positive, and I will deliver that to the right side of the button. A button, we have to think about now, what kind of pin do I want to hook it up to? Do I want to hook it up to a digital pin or an analog pin? Well, buttons just send pulses of electricity or no electricity. So there's only two things that a button can be, on or off, and that's exactly what digital is. I don't ever want to use right now Arduino pins 0 or 1, so I will hook the left side of that button up to pin 2. I'll make that a yellow wire. And so I hooked it up to digital pin 2 because that button is a digital device. Over here, our potentiometer, we always hook one terminal up to positive, so I'll hook the right terminal up to positive. And we hook the other terminal, or the opposite terminal, up to negative. And then the wiper, remember that's the one where the current is changing. So the voltage on the wiper can be a range of different things. And I hope you recognize the word range, because that's our keyword for analog. So I'm going to hook that one up to analog pin 0 or A0. So that wire right here, that green wire that I just drew, that will have voltage that's always changing depending on what I'm doing, if spinning the knob or not. So when I spin the knob, the voltage on that wire changes. Also, we'll go over here, we'll hook up one side of the photoresistor to current. That current will go through the photoresistor, and then that photoresistor will change the voltage of that current based on how bright or how dark the room is. So again, I can have a range of voltage from no electricity because it's super dark in the room, all the way up to the same amount that I put in there. And if we go back and look at the Arduino, we can see that the current is hooked up to the 5-volt pin, so we hook 5 volts of current up to this thing. So that would be a maximum of 5 volts that we get back. Anyway, that's a range. It can be 0 to 5. That is analog. So I'll go ahead and hook this guy up to the analog pin. Let's choose A5 for him. That's what your circuit should look like. I hope you've been pausing to make yours look like mine. Let's go ahead and talk about what the sketch code should look like, though. So I'll go to code, and I'm going to switch from blocks to text. I'm going to continue. All right, let's go ahead and rename the pins in the global variable section. We want to rename the pins so that it's easier to see in the program what their job or what their function is. So let's go ahead and rename pin 2 first. I have to declare the data type. Well, it's going to be digital, and digital means on or off, which is the numbers 0 for off and 1 for on. So those are whole numbers. Integers will still work, so I'll go INT, and that's actually going to be data type for the measurements. I'm sorry, I'm confusing the measurements for the pin numbers there. It's still an integer because the number 2 is an integer number, so that's INT, and I'm not going to get too creative with renaming it. I'll call it button pin. All right, and then I'll put my equal sign out because we need to assign it something. What am I assigning to button pin? I'm assigning the number 2 because it's pin number 2, and I'll give it a semicolon. So same kind of situation over here for my analog pins. So I'll go INT. Let's rename the potentiometer pin, which is A0. I'm not going to get too creative or wild here. It'll just be pot, short for potentiometer, pin. And what is the pot pin on the Arduino itself? It's pin A0. So I'll type that in, A0, and notice that is the number 0 and not the letter O. And I'll put a semicolon, and then I'll go here, and for my photoresistor, I'll go INT. I'll call that guy the photo pin, and that is going to be A5. Great. Pin mode, I'll just keep what's there. I don't want to set up pin 13 though. We have nothing attached to pin 13. I do have something attached to pin 2, and that's the button pin. So, and remember I renamed it button pin, so I do not want to type in 2. I want to type in button pin, just like that. Now, pin 2 is not sending electricity out to a light like we were doing. Instead, it's getting electricity in from the button. So this is not an output pin, it's now an input pin, and that's all in capital letters, INPUT. It is an input pin. So we have that one ready to go. I also need to go pin mode and set up the next one, which is our potentiometer pin, which we called pot pin. So pot pin, And pot pin is also listening for electricity to come in, or waiting for electricity to come in so it can measure it. So that means it's an input pin. And I hope you recognize that all three of these sensors are all going to be inputs, or the pins connected to them are input pins. So that means our photoresistor is too. So pin mode, photo pin, it's going to be an input. And before I move on to the void loop section, I just want to remind you that the job of this circuit is to send information back to a computer. So we're going to have to start the serial service, which is serial with a capital S, dot begin. Don't forget that capital S. People always want to forget that. 9600. All right, so we've got everything all set up. Now, it's going to be kind of interesting what happens here over here in the loop. I'm going to start out and I'm going to create a variable, and since that variable is inside of this function, it is not a global variable. It's what we call a local variable. And we'll stay with int, or an integer, so int. I want to create a variable that's going to remember the measurement, okay? So that variable, let's call it, for the first one, for the button, that's going to be the button pin. Sorry, that's not correct. We already have a variable called button pin. I don't want to create another variable called button pin. Instead, I want to call this one button value, or maybe button measure. Yeah, let's stay with button measure. I think that works, because this variable is going to remember the measurement from pin 2. So I'm going to hit equals. I'm not going to type a number in here though. What I'm going to do is I'm going to use a command to come up with a number. Basically, I'm going to use the measurement command here. And if you remember from robotics, we talked about this quite a bit. Measurements are always numbers. So whenever I take a measurement, I'm really creating a number. So let's go ahead and show you the way that we measure digital pins. And that's like this, digital. If I spell that right, that'd help. And then read with a capital R, R-E-A-D. That means we are going to measure a digital pin. And that measurement's not going to be too incredibly complex. If there's no electricity, the measurement is 0. If there is electricity, the measurement is going to be the number 1. So those are the only two possible numbers that could go into the variable called button measure. 0 for no electricity, 1 for, yeah, there's electricity there. So digital read, and then I need parentheses for an argument. The only argument that we need to tell it is, what are we digitally reading? Well, we're digitally reading pin 2, and if you remember from our global variables, we renamed pin 2 into button pin. So understanding what's happening on this line is probably one of the most important things you can do as we move on through Arduino here. And it's very similar to what happened in robotics when we were measuring things and remembering it in a variable. So you can see I created a local variable called button measure. And the number that I'm storing inside of button measure is going to be this digital read. That means it's going to be a measurement of the button pin. So it's going to listen for electricity on the button pin. If there's no electricity, that measurement is 0. If there is electricity, it is going to be, that measurement will be the number 1. Okay? Well, we got to do the same now for the other ones. So let's go ahead and move on to our potentiometer. So that's going to be, we'll create a variable for that, and pot is short for potentiometer, so that's going to be, let's call it pot measure. And that is going to be, now, we are not going to digitally read this pin because it is not simply an on or off device. A potentiometer sends a range of things, and that's why we hooked up to an analog pin. So instead of a digital read, we're going to do an analog, A-N-A-L-O-G, read with a capital R. And what is the thing we are analog reading? Well, the argument is the pot pin. All right, and so I'll make a little note here. Let's go make a little comment for our digital read. So digital values are 0 or 1. That's it. The analog values are a little bit different, so I'll make a note about that. Analog values are between 0 for no electricity. And remember, we put 5 volts of electricity in here, and we're measuring how much comes back. You would think that it would be between 0 and 5, but just because of the way computer memory and stuff works, that we won't get into too much detail here, it's going to be between 0 and 1023. So those are the values that I could have. My analog range goes from 0 for no electricity, and if I get all 5 volts back from the potentiometer or whatever, the number I'll get, C, is 1023 or 1023. So we have a variable for remembering the potentiometer measurement, and there's only one more that we need, int, and that's our photo measure. And again, this is hooked up to an analog pin, so we don't do a digital read, we have to do another analog read. So we'll do an analog read just like I did before. Don't forget the capital R. And what am I analog reading? Well, that's the photo pin. Okay, and this is an analog pin, so when we see the numbers from the photo pin, it's going to be between 0 and 1023. Okay, so let's go ahead and send those numbers back to the computer so we can see how much is going on there. So I'm going to use some serial commands to do that. So I'll start with serial.print. And what do I want to serial print? Well, maybe I'll say a little message like this first. So the button value or the button measurement, and I'll say equals and give it a space and then a quotation mark. So that will put on the first line, it will say button measure equals, and I'll go serial.print. Now I actually want to, because this will happen to the right of the equal sign from the previous message, right? So basically we're adding on to that line, right? What do I want to add on? Well, the button measure is what? What variable is remembering the button measure? Well, that's called button measure. So I will send that through the serial service to the computer. All right, and then what I'm going to do here is I'll do another serial print and a little custom message. I'm going to start with this one with a space so that there's a space between the last serial print, which was button measure, and this one, and I'll say this time potentiometer measure equals, and again a space before my quotation marks. And don't forget all these semicolons at the end. So that's created a little custom message on that line, and then I'll go serial.print. Well, now I actually need to put a number after that equal sign. So the number is stored in the pot measure variable. So I'll send the pot measure variable to the computer. And so I hope you've noticed that I haven't gone serial.println yet, because we put ln at the end of the line. So all three of these measurements will be on the same line of text that's going back to the computer. All right, so let's do the last one here. So that's serial.print, and I'll start that one with a space to get it away from that number, and that's going to be the photo resistor. So we'll just say photo measure equals, a little space there, quotation mark, parenthesis, semicolon. And what's the last thing I want to serial print back to the computer? Print. Now this is the very last thing in the line. So I do now want to type in serial.println. And what is the thing that the last thing that I'm sending back to the computer? That's actually the photo measure, that variable. Okay, and you know what? I'm just going to put a little bit of a delay of maybe like 200 in there, so 1/5 of a second. So I can see what's happening here. It's not going to flood my serial monitor. Okay, so let's just see what happens when I click Start Simulation. Now, all of this is being printed to this serially, so it doesn't look like anything's happening over here in the circuit because that's all happening in the serial monitor, so I'll open that up. And you can see it's telling me, uh-oh, I'm not pushing the button, but it's returning the number 1. And remember, earlier we said it would only return the number 1 if the button is being pushed. So that's weird. My Arduino thinks that the button is being pushed. The potentiometer is 0. Well, let's see if I move the potentiometer. Oh yeah, you can see the potentiometer values changing from 0 to 1023, just like we predicted. Okay, well the potentiometer seems to be working just fine. And then the photoresistor. Look at that. The photoresistor is getting back 1023. That's all 5 volts. Even though it's in the dark, it has maximum resistance. And you can see sliding the brightness thing doesn't make any difference to the value being reported back on the serial monitor. So it looks like right now, I'm going to stop simulation, that my button and my photoresistor are broken. Well, good news is they're not actually broken, guys. Instead, what's going on here is a little kind of trick of nature. This wire right here, let's look at the button, that yellow wire, is in an environment just like all of the things surrounding us. Our environment is filled with basically magnetic signals, right? We have cell phones that are emitting magnetic signals, magnets that are emitting magnetic signals, lights that are emitting magnetic signals. So whenever that wire comes into contact with a magnetic field, remember, magnets push electrons back and forth. So it's going to make pin 2 think that there are electrons moving on that wire when there aren't actually electrons moving on that wire. So what we need to do is we need to give those electrons that are moving from magnetic energy a place to go. So what I'm going to do is I'm just going to move this wire down a couple notches here closer to the button. I'm going to close out my code right now. I'm going to do a really neat trick here. If you know anything about electrons, you know that they love to go to the ground. So let's give those extra electrons a path to the ground. And I'm going to do it with a resistor just like this. So right now we see that it's a 1,000 ohm resistor. Let's make it a pretty beefy resistor though. Let's change that to a 10,000 ohm resistor. So there's the number 10, and we can see K stands for 1,000, and then our little omega symbol or the horseshoe stands for ohms. So right now, those extra electrons that are being generated from magnetic signals in the environment have a place to go to ground through that resistor now. So remember, that should be a 10,000 ohm resistor. I hope you're pausing and copying along with me. Let's see what happens now in our code. I'm going to clear my terminal. I'm going to start simulation. And you can now see, hey, I'm not pushing the button, and the button value is 0, exactly what I wanted it to be. So let's press the button and see if that turns to 1. Yeah, 0s and 1s. That's it. I've got a fully functioning digital circuit now. So this resistor that's giving all those extra electrons a place to go to the ground, that's what we call a pull-down resistor. Let's go ahead and look at our potentiometer, which was working. my potentiometer does not need a pull-down resistor. You can see that since the potentiometer is already a resistor and it's already hooked up to negative, all those extra electrons created by magnetic fields in the environment, well, those are already going to ground. So whenever I wire up a potentiometer, it does not need a pull-down resistor. But let's go to this other one. Our photoresistor, which also looked like it was broken. Our photoresistor, it looked like it was broken because this blue wire right here going back to pin A5, you guessed it, has a lot of electrons moving around back and forth because of the magnetic field of our environment. So I hope you know the cure for that. The cure is another pull-down resistor. So again, we want to put the resistor on the pin side of the device. So what I mean by that, this yellow wire is going to pin 2. That's the pin side of the button. So that resistor is plugged into the same row to negative as the yellow wire. So this guy, I'll give you a second to think about it as I change it into a 10,000 ohm resistor. Well, what side of the photo sensor do I want to hook it up to, or the photoresistor? Do I want to hook it up to the current side, or do I want to hook it up to the pin side? I hope you said pin side, because that is absolutely correct. So I'm just going to move my wire a little bit closer to the photoresistor itself, and I'm going to go on the pin side and hook that up to negative. Now, let's see if this guy works. So it is simulating. It doesn't appear as if anything happens because I have to go to my serial monitor. Now, in a dark environment, it's getting the number 54, which is a whole lot lower than the 1023 it was showing. So let's make it bright. And that gets pretty close to 1023. You can see some of the voltage from the photoresistor is going through that resistor to negative, and that's why it's not getting all the way up to 1023. But this is okay. We can still see that there's a range of brightnesses all the way from 54 when it's really dark to 974. Boy, I hope you have fun building this one, guys. I hope the rest of your day is going great. This is how we do this assignment. I know it's kind of a big one, but it's a lot of fun to build and get working on your serial monitor. All right, have a great rest of your day, folks.